And another effect that we came up with is spiral particles. I don't think we have. Well, basically, this one is really simple. We have a few layers of pretty chaotic, stringy-looking textures. It's just randomly drawn lines. And what we did is we animated these with the UV. We animated UV so that they. What is this? Yeah. So in this case, we have two layers, and we are rotating them in opposite directions, one counterclockwise, one clockwise. And the effect, so you can see it sort of have a transparent texture on it. Yeah. Nice. And the particles themselves have a node, the main subatomic particles, the muon, have a node-based material. It's based on a flame node material that we've used before. It's quite dynamic, so as it comes down, it almost looks like a comet hitting the surface. Okay. So it's go on. And another effect that I already talked about a bit is the water wave at the bottom of the screen, it's really nice because it forms a ring around the entire dome, and every time the particle hits, it makes a small splash, and it's just a nice way to terminate the particles gracefully without having it go all the way to the edge of the frame and then just disappear into the ether.
Was inspired on PS3. If I PS3 add me, oh, it doesn't work. I'm there. But it's pretty much the same effect they use in the PS3 logging screen. It's here, you can see.
For the water wave, again, Martin built most of this, I think. We're very proud of the fact that it's almost entirely shaders, meaning it does run pretty fast on most graphics cards. One of the limitations we had with this application is it's pretty CPU limited due to other particles. So this is all shaders. We are passing the location of the 12 particles, the 12 positions where the particles could hit into the shader, and the shader calculates everything on the fly using a pretty basic sine wave. So it attenuates the displacement frequency as it goes out. I think we're running, so. Yeah, I think we're running out of time, so. Just blast through everything real quick. Okay. Post-processing, we can do hue, sharpness, brightness, saturation, and gamma. And one of the nice things about the Blender game engine is that really it gives us a lot of flexibility in just experimenting. So on the last day, we decided that we really want to do something different, and we had like 3 hours left. So we came up with something that the idea is not really original, but the implementation is for Blender is new, and most people haven't seen it on such a large screen, so we thought it would be nice. So what it is a cosmic breakout game. So the particles would automatically, they would just come down and hit the bricks, and eventually all the bricks will disappear, and you have.
And you see how all the other effects happen.
And you see how all the other effects pretty much happening, and it just gives, it's something that we put together very last minute, and that just sort of goes on to prove how effective the Blender engine can be for prototyping, I think. Yeah, I think we're, and what else?
Just a quick post-marking.
Sure. So, and something we learned from this project, well, not to complain, but the performance of the Blender game engine with a large number of objects is a bit disappointing from an artist's point of view, I think, especially since considering that we are using the physics engine. When you have a lot of particles, they tend to slow down the engine. So, but that's something we sort of already know. So, but it is amazing for just rapidly trying to, make something really quick, in the last hour. It was you know, and it was an experiment not only for us but for almost all of the people involved. So for the university who came up with the project, for the producers who set up the equipment, set up the dome, set up the projectors, it was all very new technology. No one really knew how it's going to work. In fact, when we were working on the media for the dome, they were also building the dome and struggling to get the projectors all up and running. So, you know, everything was happening in parallel pretty much.
You showed read. People use a lot of internet nowadays, but books are still fun and good. And just to mention officially that Mike and I are working together in a Blender Game Engine book. As an user, we found out a lot of problems to find documentation, and it's also hard to find people using Blender Game Engine professionally. So actually, I think it's a great contribution we can give, humbly but great in a sense that we'd like to find this kind of thing, trying to bring together this kind of professional experience with the general overview, like teaching process, to be released after Blender 2.6.
And but if you pre-order now, you can get it for 25% off on Amazon. Yeah, and I think that's our cue, so we should probably. Any real quick questions? Go ahead, please.
Three questions. Repeat the question. The first one is about the fisheye projection. You went the well-known approach going through a cube map. Did you try doing a direct projection using GLSL so that you're doing a direct stereographic projection in the shader?
Okay, so the first question, just because for the streaming it doesn't record your voice, the first question was if we try to go straight from GLS shading code to create the fisheye game engine camera, or why you had to go to the cube map. That's actually explained last year. The talk is even online, you can get the video, but making longer short, basically you couldn't. We need a geometry shader, a vertex shader, and a fragment shader, and a very smart tessellation, because there are two problems. One is the cooling, that Blender basically doesn't render everything that's outside the first cooling of the camera, so we need to bypass that. The second one, that even if you have all the geometry and you simply want to render it, think about a column, for example, or a cube, you actually need to tessellate that, because if the cube is on front of the camera, we actually need to have this warped.
I can walk around with it and do stuff.
Okay.
Can you put on the other microphone technology? Okay.
Hello.
So, second question is, you know that the number of particles illuminating the scene created a huge performance hit. Did you try implementing deferred shading for that?
What was?
Deferred shading. You first draw a geometry buffer, and then for each light coming in using a post-processing shader, you can apply the light.
So basically, the Blender Game Engine doesn't work with the referred rendering. And so we had a limitation on how far we could go in terms of new features or new fix. So since we decided to go with the Blender 2.5, part of the coding budget, let's say, was house cleaning. Bug fixing, fix the Blender player, helping fix the UI, and things like that. So it would be something to explore. Something really gave some serious thought was on OpenCL. So there is someone, I'm not sure if it's here, that's actually working on OpenCL implementation for the game engine. And that would be really, really handy for particles. Because the problem is not the particle, but the number of objects you need for one single effect.
Really quick one. Can we use your rendering technique outside the game engine as well? So, for instance, to make an ang map or something similar from Blender.
We can. Do we have internet here? I don't know. We showed last year. I'm not sure I have here. I rendered some shots from Elephant Dreams using this technique. So basically, we're talking about cube maps. We can actually have, in case of Blender, you can even have the same scene. You duplicate the scene with linked objects and make the camera to be an unique object. And then the camera can be unique for each of the scenes. So you can put them together in the composite. Well, the answer is yes, it's possible. I can explain later.
I have one question about the hardware and operating systems. On your diagram, you explained how the dome system was working. And after Blender, you went to a stitching process. And then you said you had a couple of workstations being synced to be able to play back everything nicely with 6 projectors.
6 projectors.
Yeah. So what kind of, was it Unix, Linux? How did you do this? How did you manage this? So what kind of system allows you to have 6 displays at the
So
same
basically
time?
how it works is we have one Blender machine outputting through 2 DVI port 4K by 1K image, right? So it's
How did it
basically
export it? Just write it down somewhere on a disk? Or
Oh no! It was just through DVI port.
Okay.
So we have one Blender computer rendering out the image in real time and outputting it through 2 DVI port from the graphics card,
Okay.
and that data goes into another capture card that has 2 input ports, and it's basically a PC with I think HDMI input cards, and as well as 2 graphic cards as each with like 4 heads each. So this is what we call the stitching computer. The stitching computer takes the input image from Blender and slice them up into arbitrary number of output for the projector. So each projector takes its own 1080p image. So
But you didn't have to build that system yourself. It was already there.
No,
working.
it was there, but it was even very hard to find this into the commercial solution. So they actually have to work very tight with the Vision, was the company working there, is a Visual and Wings.
Yeah.
And the thing is, we actually were exporting, you saw that we're projecting a spherical panoramic, not sure remember. Basically because we're actually outputting 2 different, for 2 different computers. So we have 2 computers run in parallel, each one having receiving half of the input, therefore project for half the canvas. So it was tricky because also we had actually some seams, some overlapping problem. That was because it's really a lot of data. We considered, selling data, other solutions beforehand, but that in the end, that's made it work.
Okay, thank you.
Oh, welcome. Good thing I read the emails today.
Are you planning to have a dome for next year Blender conference?
Don't we all?
Producing some dome biomolecular movie. So we are looking for this.
Dalai wants me to do an open dome movie, right? Open movie, dome, open movie. Huh?
Yeah.
But there's even a dome projection close to the Blender Institute, across the water. The zoo has one. So we could go there and test it and do everything.
But see, we already have a dome open movie here. This is
Of course, since we were in the same week where they released Intel, of course we projected in the dome.
Yeah.
It was also, this is the credit scene of Intel. It was really cool.
Looks really good. Well, maybe did you ever try to render a 360-degree shot from Elephant Dream or Big Bug Bunny? Or
I tried Elephant Dreams, works for a lot of the scenes, because Elephant Dreams, they actually keep all the assets in the same file. They don't cheat so much. But Big Bug Bunny, first I had some problems rendering Big Bug Bunny with my computer, because it was more expensive, but a lot of things are cheated, the scenes are, and they use a lot of cameras, very far cameras. So the camera in the dome mode is always in one single place. Yeah. So actually we need to do a lot of camera work. And basically the problem is that you need to redo a lot of the art and the animation.
But you might be able to do 180 degrees, which is easier than 360.
I'm talking actually about 180, the dome, 360 by 180.
Okay.
For some scenes work well. The example for the Elephant Dreams, when they're in the washroom and the walls start moving. That's the perfect scene for a fish. This one, I made it 360 by 360.
Yeah?
The spherical panoramic.
Cool.
Yeah.
More questions?
He actually had 3 questions. Do we have the third one? Okay.
Hi. You discussed that the performance issues you have for projecting real-time 4K by 1K, but I wonder, do you are planning or thinking about synchronizing different machines so you can use more power and more display for that?
That's a really good question. I have been thinking about that since I started working with domes. because at some point the Blender game engine, well, hits a problem of the maximum resolution it can handle, and also the maximum resolution it can output. In that case, we actually had a very powerful ATI machine that could actually handle pretty much this resolution. But sometimes, such as in a cave environment, you really want completely different computers running independent. Or I was talking once with some people from New York. They have like a cylindrical canvas. They are used to have individual computers connected to the individual projectors. So there gotta be a way. I've been talking with the people from Verse. I'm not sure if someone from the Verse deving list is here. Oh, there you go. Because I was actually, I realized that Verse could actually be used for that, and they actually said that Verse was used for a sprint they made for the cave development for Blender development for the cave. So exactly to try to sync different applications. So it's something I actually want to talk with the guys and see actually what we can come up together. Yeah. So there's not yet there, but something actually, I think at some point we're going to have it.
Okay, I think it's time for lunch. So give them a big round of applause. Thank you.
Thank you, Tom. Thank you, everyone. Sorry about the time. Sorry about that.
Yeah, but we were so worried.